All right, everybody, good morning.
Good morning.
How are you guys feeling today on this Wednesday?
Good.
So today we're going to be talking about solving single-step linear equations. Okay, we love math on a Wednesday morning. So let's remember our expectations. Mary, what's one of our expectations?
Raise your hand.
Yeah. What do you think was another one? Be respectful.
Yeah, and listening to the teacher.
Okay, Leah, what do you think is one?
Don't talk over the teacher.
Don't talk over the teacher, perfect. All right, so we're gonna be using inverse operations to find the variable. Do you guys know what inverse means? Do you remember? No? Kind of means opposite, okay? If it's a plus, the opposite of a plus is a minus, yes. Okay, so at the end of today, you're gonna learn that you can solve one-step equations using inverse operations, that you can explain the steps using your vocabulary as well, okay? So how can we use inverse operations to find the value of a variable? Do you guys remember? Show of hands. No? Okay. Well, perfect. That's what we're going to learn today. Sound good? All right. So let's look at this real life connection. All right. So we have 20 bucks. All right. And you spend 7. How do you find out how much you had left? Right? So you put x minus 7 equals 13 would be the problem. Right? So what would you plug in? Why does this matter? Why does it matter for us to figure out how much we had left? And how do we use this as a life scenario in real life situations? So equations help us solve real world problems like money, time, and distance. We use math when we pass out money, count money, give people money, share money with our family, create a budget, things like that. But also when we're doing time, because you have to think, if I'm gonna get there at 6, what time do I need to leave here if it takes me 3 hours, right? So these are all real world life scenarios that you're gonna need to be able to use math, all right? So what would you plug in x? If I had $20 and I spent 7 and I had this much left, 13 left, what am I missing? What am I plugging in for x? How do we find what x is? Do you know? Nope, we're gonna learn today. Okay, so these are our key vocabulary words today. Did you know math has vocabulary words?
Yeah.
Everything has vocabulary words, correct? So the first one, we have a variable. What's a variable? Is it a number or a letter? It's a letter, okay? So it's the letter that stands for a number. So x plus 3 equals 7. So if we were to plug in a number right there, what would it be for x?
And a number?
What number would it be?
3x.
4.
Oh, 4.
4 plus 3 equals
Oh, yeah.
7,
Oh.
okay? So coefficient, a number in front of a variable. 4x equals 8, okay? And then an equation is just a simple math sentence, okay? It's a sentence with an equal sign. So x plus 5 equals 10. So it's a sentence. This creates a sentence, all right? To isolate, when you hear isolate, that means you want to get the variable alone. X plus 3 equals 7, and then equals x equals 4, correct? We plugged 4 here, right? So when I say isolate, that means we got to get that variable, the letter, on its own, okay? Inverse means opposite. What's the opposite of multiplication? Division. What's the opposite of division?
Multiply.
What's the opposite of negative?
Positive.
Okay, so those are the two that we're going to continue on using. Okay, so balance. We all know what balance is, okay? But in math, it means something different. So balance means both sides must stay equal. What we do to one, we must do to the other. Does that make sense? Okay? So those are our key vocabulary words for today. Are there any vocabulary words here that you guys have never heard before? Yes.
Balance.
Balance. Like in a math sense?
Yeah,
Yeah, using it as a math sense, but you've heard balance in like real life.
yeah.
So balance means that it must be equal, must stay equal on both sides. What I do to this one is because if I'm off balance, I'm heavier on what? One side. And so for order me to make myself balance, I have to come back to the center, correct? Okay, anybody else have any question, any ones that they were curious that they didn't know exactly what it meant?
The second one.
The second one, coefficient. That's an interesting one, yeah. So coefficient, because before you probably just thought, well, it's just a number in front of a letter. And what are you typically supposed to do when it's like that? 4x, what does that mean in math sense? Do you guys remember? Typically it's multiplication when they're right next to each other, right? Okay, all right. So inverse operation chart. So we talked about inverse means that it's basically the opposite, all right? So addition to subtraction, okay, and vice versa. Addition is the opposite of subtraction. Subtraction is the opposite of addition. Multiplication is the opposite of division, and division is the opposite of multiplication. Whatever you do to one side, do to the other, because you're supposed to do what? What's the word that we checked on? Balance it, right? Whatever you do to one side, you need to do to the other, okay? All right, so we're gonna watch, before we do an I do, we're gonna watch one little video.
In order to solve one set of equations, we must first realize that the inverse of addition is subtraction. Subtraction is addition. Addition is multiplication. Something important to remember throughout all of our equations is that what is done to one side must be done to the other. Let's get started. Our first equation, x plus 4 equals 29. Our first step is to isolate the variable. So here I have my x is right here. And I'm going to isolate my variable by asking what operation is being done to the variable. Well, I can see it's being added by 4. So what is the inverse operation of addition? Subtraction. So I will subtract 4 from both sides. These 4's will cross out because this becomes a 0 pair. Positive 4 minus 4 is 0, so then I end up with x equals 25. I can always check my answer by putting in my 25, substituting it in for x, and seeing if the answer is correct. So 25 plus 4 needs to equal 29, and it does. My next problem, 32 equals y minus 1. I will still always be isolating my variable. And I'm going to do that by asking what operation is being done to the variable. Well, this time the variable is on this side, and the operation being done to it is subtracting by 1. So what is the inverse of subtraction? Addition. So I'll add 1 to both sides this time. This time, this side is going to cross out because I have negative 1 plus 1, which is 0. So my answer is 32 plus 1, which is 33 equals y. Remember, I can substitute that in for y and see if I'm correct. 32 equals 33 minus 1, and it does. For this problem, I will still isolate the variable, which in this case is on this side, it's b. I'm going to ask what operation is being done to the variable. Well, I see there's an 11 outside here of a coefficient of 11. Remember, when a variable is next to a number and it has that means it's its coefficient, it means to multiply. So what is the inverse of multiplication? Division. So I'm going to divide both sides by 11. I always want to use a fraction bar to show division with equations, instead of using the normal division symbol. So I'm just going to draw a fraction bar under each of these terms. And I'm going to write 11 underneath to show that they're being divided by 11. So I will have b equals 6. The reason that these are going to cancel out is because 11 divided by 11 is 1, and we know that there is a coefficient of 1 in front of all variables that have no number in front of them normally. So this makes sense. 1b is equal to 6, or just b is equal to 6. Remember, I can substitute that answer in, and 11 times 6 is 66, so I'm correct. For our last example, we have 5 equals w over 10. I'll still isolate the variable, and the variable's on this side this time, by asking what operation is being done to it. Well, we just showed that a fraction bar is division in our last problem, so it's going to be w is being divided by 10. So what's the inverse of division by 10? Multiplying both sides by 10. I'm going to be using parentheses to multiply both sides instead of using the dot. This is because it can get confusing with the dot to see what's actually a decimal and what's a multiplication symbol. X can be confusing because it might be confused with a variable. So we always use parentheses. So here I'll just draw my parentheses around my first term and put a 10 outside. That means multiply by 10. I'll do the same thing to the other side. So 10 times 5. And then here I have 10 times essentially 1/10. And so those 10s will cancel out because that's really 10 divided by 10, or 1. So I end up with 50 equals W. I can plug this back in to see if I'm correct. And 50 divided by 10 is 5. So 5 equals 50 divided by 10. I'm correct. Let's recap. Steps for solving equations.
Okay, so let's fill in those blanks. Okay, steps for solving equations. Identify what blank is being done to the what? What was the question she always asked herself first? Identify what? Think real hard. What was she did first? She used the what? She circled the variable, and then she also, and what is it being done to the, oh, let's check.
Identify what operation is being done to the variable. Do the inverse operation to isolate the variable. And repeat the operation on the other side of the equation. That wraps up our lesson.
So this is what I wanted to show you. What did she do before every equation? And when we do math, it's very important to
4
walk
equals
through these
29.
steps in your head and ask
First step
yourself
is
the
to isolate
questions.
the variable.
Because first you need
So
to figure
here I
out
have my
what
x
is
right
the variable, right?
And I'm
It's
going
x.
to isolate my variable by asking what operation is being done to the variable.
So she's asking what operation is being done to the variable. So when she says what operation, she's asking what? What is she asking? She's asking what's being done, but she's asking,
Our first step is to isolate the variable. So here I have my x is right here. And I'm going to isolate my variable by asking what operation is being done to the variable. Well, I can see it's being added by 4.
so you're looking at basically, is it dividing, multiplication, addition, subtraction, correct? So you're asking, what is happening to that variable, okay? That's the first thing you're doing, because when you look at that, if it says it's adding, what's the automatic answer that you're gonna do? Subtract, because we're gonna do the what? Opposite, okay? So
what is the inverse operation of
then you
addition?
look and see what's the opposite of that operation.
So
I need to do,
subtract 4 from both
subtract.
sides.
okay? So you have a whiteboard in front of you, Okay, I want you guys to grab one. Okay, so first, we're gonna work on this together. So first, our first example is, I wanna isolate this, correct? I'm identifying what my variable is, and the variable is x, all right? So second, I'm gonna ask myself, what is the inverse equation? In my head, I automatically know it's a negative. I'm subtracting, correct? So my first goal, I isolate x, okay? What is the opposite of plus 7? It's negative 7. If I do it here, I need to do it where? The other side. Say, okay? So now, a positive 7 and a negative 7, that cancels out because that equals 0, correct? So we're gonna cross that out. Now, am I adding 7 or subtracting 7? Subtracting 7. So 7 minus 12 is 5. So my answer is x equals 5. Is it always good to check your work? Always good to double check your work. You want to plug it in. Plus 7 equals 12. Okay, so now I know my answer is correct. So right here in your head, I use the inverse of addition to get x by itself. I use the opposite of addition, correct? Just think of this big word, that's this inverse, as opposite. Okay? All right. Now, we do it together. Let's do it together. All right? So, we want to look at x minus 9 equals 6. Let's do that first one together. Everybody put x minus 9 equals 6. So first step, Mary, what's our first step? What do we do? Which one is it? X. Circle it up. Okay, put that circle on. Now, what is our inverse? The opposite. We're adding, right? So now what do we do? Add 9 to where? Both sides. Okay? And then what do you get, Layla? Tell me what you get.
15.
You get 15? Yeah. So we add 9, and we get 15. So x equals what, Leah?
15.
Perfect. Let's answer the first question. Okay? Leah, can you read that to me?
To isolate the variable,
What'd you do? Added, yeah. Because blank is the inverse of, because blank, what's the opposite of addition?
subtract,
Is the inverse of,
addition.
yeah. Good job. Perfect. All right, so let's write the next one. Here we go. 4x equals 12. Ooh, we haven't done a multiplication one, right? Okay, so what are we doing? First, Mary, what are we doing? Identify the variable. And what is that, Leah?
The x,
Perfect. All right. Layla, what do we do next? If we're multiplying, what are we doing opposite?
you divide.
You divide. Good job. And when we identify dividing, do we put this symbol? No. What do we do?
You do a line over the 12.
So what we do over this side, we have to do,
On the other.
because we always need to do what? What's the word? Starts with a B? Balance it. All right. So now, what's our answer, Mary? X equals 3. Does 4 equal 12? 4 times 3 equal 12? Yes, so we checked. So to isolate the variable, you what first? Did you multiply or divide? We divided because blank is the inverse of what? What's the opposite of divide? Multiply. Perfect, and divide. Good. All right, last one. Ooh, that's different. What does that mean to you? Same as if it was like this. It's the same as if it was like this. Okay? So what are we doing? Identify the what? Variable. Now, is this division or multiplication? Division. So now what do we need to do? Multiply. So now, okay. Right? Do these cross each other out? Yep, and the answer is perfect. Awesome. Let's just say it together. Can we all say it together? To isolate the variable I what? Multiplied, right? And because the what was the opposite? Division, the inverse of multiplication. Good job. Excellent. All right. So now I want you to try these 3 on your own and do them on your board, and I'll walk around and check and see. You have an eraser right here you can use. Oh, okay. This is, oh. All right, just write over it. You can do it. Do you need help?
Yeah.
You need some help? All right, so how do you identify? Perfect. Opposite of that is subtraction. 10 minus 6 is
4.
perfect. All right, next one. You need help. Is this multiplication or division? When they're right next to each other. Multiplication. So we are going to identify our variable, or circle our x, okay? And we're gonna multiply 2 on both sides, correct? I'm sorry, divide.
Oh.
Sorry, my fault. See, you didn't catch me. You didn't catch my mistake. The opposite of multiply is what? Division. So we're doing our line underneath each, okay, perfect. And then our 2 cancels out y, because it goes into 1, and 2 divided by 14 is what? What's half of 14?
7.
Perfect. So x equals 7. Yeah, great. Last one. All right, we're gonna play a quick game. Does anybody anybody have any questions?
What thing is it?
Bingo.
Oh.
Here's this paper, put your name on it. You're gonna do all your work on this paper. This is gonna be your scrap sheet. Okay? Everybody grab a bingo card. Okay. Everybody needs a few of these. Few of these. This is your paper for scrap paper, okay? That's what you're gonna write your equations on. So I can check your work. All right. All right, bingo it is. Here we go. One-step equations. We all know you can put a dauber on the free space, and we're playing classic bingo today, all right? All right, the first one that you are going to write is, I will put it on the board. Let me find my whiteboard. Okay, that's not it. We'll try that. Your first equation, okay? X minus 8 equals 4. Negative 4. Ooh, we didn't do that. What's the opposite? Identify your what? What's the opposite of minus? Addition. Okay? So you're gonna do what? Add 8. Add 8. So now we have a negative 4 and a plus 8. A negative and a positive equals a positive, right? So when the answer will be equals 4. Okay?
Oh.
Okay? All right, did you get that one?
No.
Anybody have that answer on the bingo card?
Yeah.
No?
I do.
Did you write the equation down? Perfect. All right, okay, here we go. Here's our next one. This one, it will be an easy one for you. Okay, 9 equals x minus 1. First step, Layla, get that on there. Ooh, Mary's on a roll. Work through the problem. You're gonna be positive, right? Plus 1 plus 9 is what?
10.
All right, so x equals,
10.
yep. Ooh, you don't have it. Oh, yeah, you do. What you got? You got 10? Ooh, you gotta put one on your free space. Okay. Here we go. Let me find a good one. All right. W plus 6 equals 28. Now we haven't used another letter, so what is our variable? Yeah, W. What's the opposite of 6? Plus 6? Those equal out. All right, who's got 22? Well, Mary right, he's getting closer again. Here we go. Good stuff. All right, here we go. This is gonna be a little bit different. Automatically, what's it look like? Huh? Yes. But that looks different, right? Oh no. Identify the variable. Here it is. And we are, what's the opposite of division?
Multiplication.
Multiplication.
Yeah.
So now what do we do?
Multiply.
Multiply on what? Both sides, right? So does this cancel out? Okay. Does this cancel out? So what's our answer?
17.
There you go. M equals 17. Good job. You guys worked through that one great. Anybody have that one on the Rico card?
Yeah. Yeah.
You did? All right, H over 3 equals, ooh. Automatically we know that this is, our inverse operation is the opposite of division?
Multiply.
Yeah. So what are we multiplying?
3 and 7. Oh,
Perfect.
yeah.
We cross those out, right?
Mm-hmm.
What's 3 times 7?
I don't know.
What's 3 times 7? Mary, what's 3 times 7? Perfect, 21. The answer is 21. Who's got 21 so far? Who's closest? Ooh, ooh. Okay. We have time for a couple more, okay? If we don't finish today, we'll finish tomorrow. All right, 2 plus G equals -2. Ooh. What do we do? Subtract, correct? So, we subtract 2 here, right? And that cancels out, correct? And we subtract 2 here, and what do we get?
No, equals -4.
Perfect! Layla! Do you guys have that answer? Oh,
Yeah,
man.
I have one more.
Good job today, you guys. What did we learn today? One-step equations. Give yourself a round of applause.
Yay!
Yay!